Hey there, this is Mark again, and this will be our last segment for today. I have Thomas Shanks here with his new project called CoPico, I think is how it's pronounced. Basically, it is a Pico Raspberry Pi connected to Coco for, I believe, network access, but I'm sure there's some other stuff. I don't know much about it, but it is all you, Thomas. Go for it.
Yeah. So here, Meg, this. Oh goodness, there we go. There's the
Yeah,
board.
there we go.
So yep, there we go. So there's the board, and here it is assembled. So what we got here is basically we've got a cartridge that puts this. This is the RP2040 based Raspberry Pi Pico sort of microcontroller dev board. So this gives us Wi-Fi and a 32-bit CPU microcontroller actually on the bus. And so yeah, what do we want to do with that is kind of the question. Like there's lots of stuff we can do with that. It's not just Wi-Fi. So that's the idea. I mean, none of the rest of the stuff's working yet. I mean, all the work I've done on this has been this year, so last couple of months. So yeah, let me screen share the website. So in lieu of slides.
Sweet.
Okay. So, alrighty. So here we have, show me. So you have the logo here. So basically, right here. So there's the logo, and we can scroll down. Here's a picture of the board, and here's the back of it with thanks to Henry Strickland and Ray, who not only assisted with KiCad, but also created these. Let's see, right? I have to put it here. These boards. This is an extender board, so you can. It's like it's not really two cartridge connectors, so you could add something and make it into that. It's just a nice little way to get it out to work on it and probe it, which is I'm doing a lot of. So
Thomas, we're still looking at the web page, so we don't see the extender.
Okay. All right. So I don't know how to tell it to go to split screen. I thought I told it that already. Where did they move that to? Okay. All right. So let me go in. And so like you can go to, this is a CoPico project.github.io. And here we have a little bit of a slide about the things we might be able to do with this. As Strick there talked about his Axiom boot ROM, where you can kind of it connects to a server and you can pick a number and boot any of a number of things, and also his libraries. Of course, we're going to get those ported over since Strick is doing the 6809 side of the code kind of here. Basically already has. It's just a matter of compatibility or driver for another network device on top of what's already there. Because we have a microcontroller at line speed directly on the bus, we can also emulate a cartridge. We have that working. Well, we have something that proves that could work working, which Strick can describe more later, called spoon feeding. But we also would have sort of standard cartridge boot process rather than sort of overriding the ROM, which is spoon feeding does. The basic ROM, like it's interrupting the boot process versus being like a game, like a normal boot, like the Axiom does. So the other cool thing that I really want to do with this is to stream out a capture of everything that's going on the bus. It's yet to be seen exactly how that's going to work. If I can't get it to the network, then I may have to go to an SD card until I can throw another RP2040 on there to make it easier to stream that out. But I really want to be able to, just like with Strick. Strick has an emulator he's written, a Micro OS 9 Gnostic emulator, and it has this kind of it matches up the code that it finds essentially the object, it matches up the object code to the source and shows you the source. It's not really disassembling, but I mean, you can use the same thing literally. So if you can just feed that in, you could actually see what's executing in the trace and match it up. So that would be real nice to have. And and another thing, I don't know if anybody knows, there's an Apple II video card that's just basically an RP2040 and some glue logic. So and then a VGA port, like some some resistor ladders and a VGA port basically. So we know we can do that. There's also HDMI that's been implemented with RP2040s. So, whether we're going to fit that on the board or make a little daughter board, or more likely a little cable that comes out and a little thing that sits there. Something along the lines of the LumaCode stuff they have going on with Commodore, except for you don't have to bug the chip. It's going to rebuild it from capturing the contents of video memory instead of letting the chip generate it. So it won't look exactly like the chip does. But the nice part is whatever library we write can also be used with the emulator. Same library. So to generate the screens. So that's going to be like later this year. I have to work with Strick there on figuring out how to do that. So and here's the schematic. It's kind of small on the screen. I just go to the website. It's on the main website, and then here's the repos, which are linked right on CoPico project, copico-project.github.io. That's the GitHub website, which also has links to the GitHub repositories. So, and really, what are the state of things? The state of things is the hardware works, and I'm doing a lot of work on. Let me stop sharing here. I'm doing a lot of work on the software, but it's definitely not ready for prime time. That's where we are. So, we were scrambling before this to try to get the proving that we can do things on the network and getting it onto the Coco put together. And I had it working at one point. Then I tried to enhance it, and then okay, that didn't work. Let's go back. Wait, why isn't that working? Did I not save the one that worked? I didn't save the good copy, right? Like I checked something in, but it must have been without one little piece. So I got spent the last few hours digging into that. But yeah, we have all the little pieces tested. We know that the card can talk to the bus cleanly. We know that it can talk to the network cleanly. We just have to put that together cleanly. So, and then we have to give a nice API, register based. It might resemble the WizNet, but I also want a low level kind of interface. So maybe, I don't know whether to describe it as multiple modes or just kind of a register based. I don't know if you've written drivers before, but a register based kind of, a command register and a data register kind of thing. And it's going to use the same addresses as the in memory. So the same kind of way you kind of write to a special address in FF7 ABCDEF as the WizNet ends up being mapped to, and that's simply because I figured out why it's done that way already, because the glue logic was easy.
Exactly.
Yeah, the 74LS chips. It was a simpler thing to grab those. And I ended up with both the same two ranges, 6.8 to 6 FF6.8 to FF6F and FF7.8 to FF7F. Because I have a 13 input NAND gate. Run it in. Okay, the best I can do is get both of those ranges.
Except in the FF7 range, you cannot use E or F at the very top. Coco 3 lives there.
Okay, that's informative. I can handle that in software. I'll just have to not seize the bus at that point, or not drive the bus.
And that's why the tests I wrote are using A and B.
Curtis had a question about ROM size on Coco 1.2. Was that answered? 16K, right?
I think we're aiming for 8K in the next version.
Okay.
Or you're asking about the internals, like the base.
I think it's the window that the Coco 1.2 can handle.
What can you load in there? Yeah, and I
Yeah,
believe
so
Curtis is right.
You can have a
that
double
space
card,
is empty, and so you could take it over, even though it's not officially yours to take.
That's right.
Okay.
So 8K is the normal size, right? And then
Yes,
16K that you can just be two cartridges basically, right? Yeah. Use both
except for
cartridge.
stomping on the wrong Coco if you plug it in.
Yeah.
Right. So,
Yeah. Oh, is that run into reserved stuff on Coco 3?
yeah, because on the Coco 3, you've got the extended basic crammed in there and all kinds of the
Oh,
super
right. And
extended.
what about disk basic?
Yeah.
Disk basic comes out of the
Super extended basic is crammed in where there used to be a blank.
There we go.
Yeah, that has
Coco
to be
3
fit in there. Yeah.
Coco 3 has other tricks though, because like some of those cartridges are 32K ROMs. They can bank switch in.
It wasn't RoboCop like 64
Yeah.
or 128 with
Something
windowing.
nasty.
How did they do that in the hardware? How did
There's
they do that in
extra
the hardware?
hardware.
Somebody have a schematic?
There's extra hardware in the
Yes.
cartridge.
Memory mapping unit.
So to map them, yeah.
Yeah,
so
and speaking of interesting cartridges, I know we're getting kind of off topic here, but hopefully it's entertaining. Speaking of interesting cartridges, the audio spectrum analyzer. What's it called? Yeah, audio spectrum analyzer. This cartridge, the cartridge is downstairs. But that cartridge does something interesting. I wonder if anybody knows or can dig up the schematic faster than I can. How that cartridge does a basic kind of bucketing spec, I guess FFT or something to figure out. I can't be doing real FFT, can it?
Whose name is on it?
Oh, it's a Radio Shack color.
It's Steve Bjork's program.
Steve Bjork, yeah.
Yeah, that actually, when he actually said, he told us that he actually hand wrote the code. He did not have an assembler. He hand wrote it.
Wow. He was young, huh?
Yeah, those were the days.
I mean, I guess the only time I've hand assembled was when I was TAing the FPGA course, and we each had our own processor, and we had one of the tasks was to hand assemble, so I had to show how to do it. Sort of,
leave 2 bytes for a jump address.
Yeah.
Oh, this is the address. Go back, fill it in.
Design your ISA, basically, yeah. So,
Yeah, so also,
but yeah,
I was going to say, Thomas, as long as you've got SlimB, you can take a lot of that ROM base over and
oh yeah, you can
override what's in the
almost
machine.
anything. What exactly can't you override on a Coco 3 with SlimB? Besides,
I have yet to figure out the details on that.
You can't interrupt the gimme getting video, memory.
When I look at schematic, it looks like RAM is problematic.
Right.
I don't think anything in the lower 32K you can have. So,
well, the Coco has the whole deal
about it.
The Coco has the whole deal about sometimes you're accessing RAM, not ROMs, no matter what you do with SlimB, because it's special boot up gimme map modes. So you have to deal with that whenever you're trying to pull a fast one on a Coco 3. Otherwise, you'll mess up the RAM image that's in the Coco 3 when you make the right stuff.
There's that device. There's that device that kind of acts like a gimme for a Coco 2, right? It's a cartridge, right? So it of course is using SlimB for that. I mean, couldn't be doing it any other way.
You're talking about the MOOH, the MOOH.
Yeah, MOOH.
Yeah, it adds lots of RAM and stuff to the.
So I mean, it uses SlimB, I would assume.
It uses SlimB.
Yeah, I mean, and some people have brought up, well, why don't you just add more RAM? I'm like, well, first of all, the microcontroller doesn't have room for that and something else, but we can throw another one on there. They're only $2. So we could throw more of these microcontrollers on the card. In fact, I want to dedicate one to being a bus transceiver, and then through the 5-volt level, 3.3-volt level shifter, level shifters, and then we can focus. Then we can do the logic capture and stuff. We can stream it over some kind of SPI or some kind of fixed binary serial format. There's something that we can use to stream the capture of all of the lines on the cartridge, not just address and data. That would be useful for the the logic capture as well. So just to have another Pico or at least another RP2040. I'd like to eventually integrate at least that one on board, make it a 4-layer board, because there's not room for 3 Pico boards on there.
That would be amazing.
And you know, I mean, I've also thought about, you know, making this for other platforms, you know, like for other platforms, if you're going in a slot, you can make a little darter card that kind of snaps on there, just like a hat on a Pi, on a Raspberry Pi. But that's going to be difficult inside a cart. So, I mean, if we're going to do like VGA or something, we're going to have a little cable coming out, right? Luma code kind of thing. You know, some kind of streaming the video memory contents out to a you know, some device that maybe even just generate Luma code. I thought about that, like, well, why would you generate the code that's made by some other chip, right? But I mean, if it's easy to generate,
what is Luma codes?
And let somebody else make it work. Yeah. The Luma code is a captured. It's you put like an interposer on the video chipset, or the video chip on a Commodore, and it streams out on a 2-wire, like on RCA jack, a digital video signal that then you feed into an input board that's plugged into a Raspberry Pi Zero, which is an actual like you know, general purpose computer rather than microcontroller, that actually, you know, is already very good at generating HDMI because it's a general purpose Linux box this big, right? So, you know, why not at least use the latter part of that, you know, because why would you want to write like the code to generate HDMI? But yeah, the point is that this is a solved problem in several different ways, and whatever's the shortest route to making something that's pleasant, you know, like solid and works for most of the users. So, you know, people are already complaining they can't find a way to get VGA in. So, yeah. So anyway, like, what, given the company here, what would you all think like to see from this, other than kind of being a you know, both a WizNet and maybe also a lower level network device, however I write the firmware is how it'll act.
Right. I think your idea of a general purpose I/O into out of CoPico device is a great way to go. And then what you do with it, you can always add more things, but once you have that basis,
yeah,
of, you know, it can get.
Well, I mean, it's open source. Like somebody else can slap their own name on it as long as they
whatever
include the copyright somewhere. You know, they can go sell this and make money if they want. So it's MIT licensed. Hopefully they contribute back, but it's not a built-in requirement, at least of the code of what I've done so far. You know, like the firmware, there's not much to the firmware yet, so it's a bunch of little proof of concept and test code, so to prove that the hardware works and stuff. But you know, when we have the whole, you know, API solidified there, the, you know, the hardware, you know, programming interface solidified there, you know, whether we wanted to act like WizNet or act like sorry, what is that? I'm trying to remember. Not what is the multi-platform?
The ABUS thing?
Fuji
Oh, the
protocol?
FujiNet. Yeah.
FujiNet stuff?
Sorry. Yeah, FujiNet. Yeah. So yeah, and there's another thing we're looking at FujiNet to figure out how to sort of bridge over to FujiNet. I mean, that's really a strict side of things at this point, because the plan is not necessarily to stick an ESP32 on there, but get the data off to streamed out to a web browser or something running, you know, a package running container on a laptop, preferably a web browser. It'd be real nice if you could do the logic capture in a web browser. You know, you have to do, you know, you have to just go to this web page and it would use an SD card to feed that to your browser, and your browser would do all the hard work. Go ahead.
No, I was just saying that's a perfect idea. Barf out HTML and, you know, let somebody else render.
Yeah, I mean, TypeScript, JavaScript stuff that's going to run in your browser, and your browser can do the your browser can use a whole ton of RAM loading all this
Internet Explorer 6 required.
Reverse it, and your browser can render the video, right? Like we can stream the video memory contents to your browser. It can render the screen in JavaScript. So
yeah,
I'm really good at web pages that kill browsers.
Nice.
Well, I mean, I think we want to write it in kind of generic kind of JavaScript, not focus on the UI side of things, but like, like JavaScript can be tested in Node and doesn't have to talk to a browser and then spits out the picture, and then we can use off the shelf stuff to get that into a, an actual web browser versus running it. Not that I'm a huge Node enthusiast, but it's the way you can have code that runs both in the browser. It's not really another good way to do that. So, it's still mostly single-threaded, right? So I wrote some Node back in the day for a project to automate stuff in a car. I don't know why they didn't use Lua, but yeah.
Mhm.
Anyway, yeah, so the Wi-Fi is going to work. Initially, you're going to just throw a, the SSID and password in a file on the, in the, I don't know what you call it, Founders Edition, Incomplete Edition in May. Some assembly required edition. That's probably what I should call it.
Yes. So that
SAR.
that CoPico chip has a good bit of flash storage that you can preload
A few megs
on, put your credentials, and
yeah, a few megs, and you can also, as long as you're not doing it all the time, as long as you're not continuously streaming data off an SD card, you can connect it to an SD card and get some stuff off of it. SD cards can speak SPI, so you just need a few wires running over the SD card. You still need that, the dedicated RP2040 to handle the bus thing, because we don't have any lines left over right now. If we want to get all, like you got 24 just from the address and the data, right? And then you only get like a few more than that, right? So
yeah, that's the problem. We run out of pins.
We're gonna try a shift register, but I kind of like the idea of having a sort of I don't want to say soft core. That sounds like something for an FPGA, but libraries or code for RP2040 that anyone else can use to bust receive an 8-bit machine. If they want to, they can dedicated RP2040, and then if they want to throw an ESP32 behind that and call it FujiNet, that a FujiNet board. Turns out I think FujiNet is considering this already, or in the middle of prototyping it. But if they don't get it out first, I'm not trying to beat them to the punch, but as much as enjoy solving the problems.
It's a natural direction.
Myself. So, but yeah. So we'll both engineer something with a dedicated RP2040 for dealing with the bus, and take when those are both out, when FujiNet gets theirs out, and I get mine out. We'll see who did get the best ideas and improve both products in the end, right? So.
Well, now that you've been on a Coco Nation show, you have been infected with feature creep. You have to work it out best you can.
You saw my slides. I think I already had it.
Yeah, well, you got it worse now.
It's like, okay, we're gonna capture it, we're gonna disassemble it, we're gonna render it in your browser.
Shove HDMI out of it. I like it. It's a good thing to spare.
So, well, some of these are solved problems. Like clearly there's that card. I have it somewhere over here. There's that card for the Apple II that's just an RP2040 and some 74LS chips and some level shifters and some resistors, and then a VGA port. That's it. So you can do a lot with the RP2040 because it has these dedicated PIO processors. That's what's they're basically a dedicated bit banging processor that can bit bang at 100 megahertz. And there's depending on how you look at it, 2 or 8 of them. There's really it's really 2 multi-threaded modules, right? And so there's four threads per module. Think of it that way. And they have a very short program they run, like just 32 instructions, like 64 bytes or something. But that's surprisingly enough to do. Like people can not implemented VGA, and it's almost all PIO and DMA, so the CPU is doing very little of the work on the Pico, the general purpose CPU, cores. So like this PIO idea, which I think that, it's kind of based on some DSPs having dedicated cores for this kind of thing, as well as GPUs having their very short program fixed kind of repeating behavior. Like they put those ideas together, and the PIO was already kind of an idea out there, but they sort of brought it to the masses with a $2 little processor designed to be the best tens of megahertz glue logic chip you can get for $2. For actually, I mean, you would need multiple chips to be able to do this, for under $10, I think.
When this chip came out in 2020, right? One of the claims in the bullet points was it could do 8-bit buses, like retro buses, but there was no demos of this. And in the last couple of years, more and more examples are starting to be seen of figuring out how to do it.
And I think it's important to kind of see what other projects out there and reach out to them and share ideas and strategies, and maybe even have common code. Like I said, have a common firmware basically or common firmware library for handling 8-bit buses. I mean, I've got Apple IIs that I've
from
Apple II is my childhood platform. So, but CoPico is the one that I've been digging into most recently, and the one I know more about at the moment, until my memory from being 7 years old and writing 6502 assembly, is not fresh. So,
and at the level that the CoPico sees the 8-bit bus, it hardly knows if it's talking to a 6502 or a 6809 or Z80. They're all very similar at this level.
It's just like wait for this edge and then grab all these lines.
Yeah.
It can grab 32. It can grab up to 32, a parallel bus of up to 32 lines in a single instruction, a single 100 megahertz cycle.
But it doesn't have 32
like,
lines
okay,
to
you
grab.
see this edge, next cycle, grab everything.
But it doesn't have 32 lines to grab, Thomas. It's
it has 32 total, basically, roughly
really?
32 total. So like once you start, you need all those control lines. Yeah, you're gonna have to have some kind of mux demux or parallel serial kind of glue logic or another RP2040. And with another RP2040, I feel like that's the easiest way to kind of free up a bunch of pins, and a bunch of and also the PIOs of the one that's on the the Pico W. That's the official one of the 2 official dev boards that has the Wi-Fi chip. It's $6 instead of $5, I believe, for that dev board. And the chips on it are worth $3 instead of $2. So in small quantities, it's still going to cost a bit to make these, probably tens of dollars, 10, $20, but plus blood, sweat, and tears for probably an hour aboard or more. But that's eventually they could could all be handled at the CM facility it's building the boards, if it's all as long as you don't need, I guess, except for they charge a bit for through hole stuff. So probably would still need, if there's any 74LS logic that's not available in SOIC.
You can find equivalents, I think.
Right. Well,
I think everything is available in SOIC. Yeah. Some things are completely discontinued, so all you got is the new old stock tip. So go ahead.
I was just saying the problem with LS logic is it comes and goes. So I need LS30s, which I can usually get installed for me, but sometimes I have to get out my hairdryer and put them on myself because they just weren't in the chain at the exact moment that I had my boards made. It's just a simple old chip that nobody stocks it anymore,
and we're using it too.
Well, Janko is the kings of new old stock, you know, for 80s, 90s dip chips. Jameco is the same ones that make the breadboards and stuff. They're located in the Bay Area. So you can actually do a pickup order with them, but they've made it a little more difficult. I think you have to like put in his will call and then email them. But yeah, you can. I got it mailed because it was like $4. So this is the next day. So, but yeah, they had all but one chip they were looking for, which I think was available new from DigiKey. So one of the, and then of course the level shifters we're using are the AVC 245. 74. It's an AVC or ACT. I'm sorry, LVC 74 LVC 245. Right. So that's the one. All right. So sorry. And so and we also consider the 4245, which is the one that actually sends 5 volts. It can go from 3.3 volts up to 5 volts, as well as back. But it turns out the 6809 doesn't care if you're giving it 3.3 volts. But you know, it might care in some circumstances, like if your MPI is dragging things down, or your other card's dragging things down, or you've got some really long cable connected to your debug card, because you can actually take 2 of these debug cards my girlfriend made and connect them together like this, and then you almost it's almost an MPI. It kind of works. So we just need to throw a little more on here, and you can have an MPI made of 2 of these. So.
Has anybody ever used Find Chips or Octopart to locate hard to find things?
I have, because Google linked me there when I was searching. So yes.
Yeah, I've noticed there's I'm trying to remember the name, begins with an R. There's a company that seems to have a bunch of old stuff. And I think they basically got licenses to manufacture or distribute older products. It's not Rockland, but I have to do a search for something old. But anyway, sometimes that'll turn stuff up, which is kind of nice.
I want to make sure we have enough time to cover what Strick worked on that became a part of this project at his request. You made sure
Definitely
to have certain signals. It's the spoon feeding. So
right. We got 20-30 minutes, so let's go for it.
Yeah. So spoon feeding is basically you assert the SLINB line pretty much continuously during boot. Actually, and don't let the basic ROMs execute. Line. You also, yes, currently you are using halt to slow things down so that not fully optimized code can keep up. You can probably get some more of it into PIO ahead of time and not need to halt it as more than once, I think, eventually. But at the moment, it works fine with the halt, and without it, it can be a little flakier because right now we're kind of Strick's code is predicting or he's determined exactly how many cycles between halt and when execution begins. So
let's tell what this does.
Yeah, go ahead.
Yeah, so the idea here is to not need a boot ROM. And one way to not need a boot ROM on a card with a Raspberry Pi Pico is to turn the Pico into a ROM where it actually looks at the addresses coming in. But I came up with this other way, which is, and so what Thomas is showing now is his icon is a spoon-fed program. Yeah, like he started to say, we halt the processor when we see reset. And when reset goes back up, we continue to hold halt down until the exact moment we're ready. And we synchronize the number of cycles. And then when the processor goes to read the reset vector, we use SLINB to turn off any other ROMs that were back there. And we put exactly what we want on the data bus for those 2 cycles. And we assert halt again. So the processor's halted until we get the next part set up in the Pi Pico, so that when we unhalt it, instead of letting it execute the instructions that it's finding in ROM or RAM, we're again going to substitute instructions. And so we spoon feed it a load D immediate followed by a store D extended. And this way, we're loading bytes into RAM 2 bytes at a time to fill it whatever our initial program is going to be into RAM. And then we spoon feed a jump instruction to make it go jump into our RAM. And we quit using halt and we stay out of the way after there. So it's a way to get a little scrap of code or even a big scrap of code into RAM without ever using a boot ROM. And so what's kind of interesting when Thomas plays this game of life here that is a spoon fit, that didn't quite land, did it? Oh, here it comes. Here it comes. Yeah, now it's
No, it
working.
was just working. It was
Yeah.
just working on it. It was still
Yeah.
halted, and there's a little delay. Yeah.
Since
Again, with it's not fully optimized, so we can slow the already slow 6809 down with halt until we catch up.
Since no basic ROM has run, and what the initialization does usually is set your VDG screen to 0400 hex. Our screen is still at 0000 hex right there, and that kind of proves that the ROM didn't execute, that the hardware is in its really pure initialized state instead of what it's usually in if you put a ROM at C1000 in a cartridge and it gets jumped to from the basic ROM.
I'm gonna boot it another time, so
anyway, we have a working demo that this actually works, and is
it feels kind of like we're
viable way
glitching glitching a you know, it's kind of like it feels kind of like we're reverse engineering glitching something to get it to go run like, you know, Doom or something. But no, we're just telling the basic ROMs to shut up and then feeding code straight to the processor.
And so actually the address that we gave as the reset vector hardly matters. I always give it an address that's in the ROM space because I know the ROMs obey SLNB really well. And we're doing this on a Coco 2. Everything we've done has been on a Coco 2 so far. We know that Coco 3s are going to present problems we have to figure out, and we hope that we can conquer.
I don't know if our remote hardware debugger will have a backstep button on Coco 3 if it can't fully bend the platform to our will.
Mm-hmm.
Go ahead.
Yeah, I'm gonna leave it at that. If people want to see more about it, I put up a wiki page, wiki.yak.net/1181, wiki.yak.net/1181. And I've also got some oscilloscope traces so you can see kind of how it actually works. All right, and I think with that, I'm finished.
Until you write something more.
All right, so here we can at least briefly screen share. So this is kind of low res, but let me see if I can zoom out a few times. And there it goes. Okay, so this is the file here. So yeah, this is just hard coded the contents of the quote unquote ROM here. And after that, it's like got all these control lines, and it's here's the PIO program. It's like it waits on this so this PIO program is initiated
by seeing E low and then high, and then as soon as it goes lows again, it's the beginning of a cycle, and that's where we can
where we can
kick.
And then we wait a certain number of cycles, and then Then there's an exact, predetermined timing just from the, the data sheet of the processor, basically, that there's so many cycles between raising, between when you turn off SlimB and or reset, or the two of them in combination, then
Now you mean halt.
exactly what it's going to do.
You mean
Sorry.
halt.
Yeah, halt.
Yeah.
Halt and SlimB. Yes. Thank you.
I don't only do SlimB when we're actually driving the data bus. To be polite, I keep SlimB off the rest of the time.
Right. So, we can clean this code up some more for readability as time goes on. We're still kind of developing this. So yeah, it's like so there's the code, and that's in one of Strick's repos, github.com/strickyak, and then it's under Spoonfeeder.
Actually, I'm gonna do a screen share too now, Thomas. Let me see if I can
Okie doke.
I can do it. I want a window capture.
Turn back into a. Let me turn back into a human rather than a Coco.
Okay. All right.
To your human form.
I am not a Coco.
And the one I want.
Yeah, my Discord name is Thomas is a cat. So
Curtis asked, do you move the DP out of the 000 range then?
No, I haven't. That might be an issue. Yeah. All right. Am I screencasting now? Yes.
You are.
Yes.
Yeah. So this is the wiki page I told you about, wiki.yak.net 1181. The signals that get used on the Coco side, E and reset are going to the CoPico, and halt and SlimB are coming back, and D0 through D7 are coming back. But halt and SlimB, in order to be polite and play well with others, should be open collector outputs, and the D0 through D7 should also well, at least be bi-state. You should be able to, you're not driving them except when you're asserting SlimB. And here's the halt timing, or the reset timing. We see reset drop, and then we pull down halt. And reset goes back up, step 3. But, and at that point, 4, we signal the main CPU thread. 5, the main CPU sets up a new state machine, and then it waits half a second so that anything else that needs reset has time to get reset, and it starts the state machine. And the state machine is going to synchronize on E, like steps 1, 2, and 3. It looks for those edges, and then it lets go of halt so that one instruction, I'm sorry, so that the reset vector can happen. We count 4 cycles, and then we put data like A0, 0, 0 to be our data bus, to be our reset vector. And we assert halt again so that the next instruction does not start until we get prepared to do it again. So now, after a while, we've got the next state machine set up, ready to give 6 bytes, and it's an LDD instruction. So like CC 3460 is an LDD of a push SYU instruction, and then STD, we're storing that at 0200, and we let halt up just long enough to get the second instruction started, and then we halt again. Now, it turns out an LDD has 3 fetch cycles and no extra execute cycles. The STD, of course, is going to get followed by, well, there's a dead cycle and then 2 write cycles, but doesn't really matter. We're not participating in that. And we repeat this over and over and over again until we've loaded what we want. So my summary is we spoon feed the reset vector. We spoon feed these LD store D pairs for the whole program. And then, so it fits in the same code, we load D with something bogus, and we jump to where we want to run and release the halt line. And this first scope trace kind of shows if you hold down halt for a long time and then you let it go, this shows you after a few E cycles that things start happening again. So the purple is E, the blue is address 0, and the green is read write. And you can see how the read write line goes into this kind of intermediate state, somewhere between 1 and 0, weirdly, while the thing is halted. So from the read write, I can see that the CPU is really halting. And here is the spoon feeding of 6 cycles. The top signal in yellow is a debug output that just says, these are the 6 cycles when I'm putting the instructions on the bus. Purple is E again. The blue is address 0, and the green is read write. So you can see that we're substituting in our own opcodes at alternating even odd addresses on address 0, and the read write is in the read mode. And then you see after we finish spoon feeding, the read write drops for 2 cycles while the CPU is obeying the store D instruction, and then it goes off floating again because we used halt. A little picture of me and my debug setup with oscilloscope probes on the board with the CoPico W. And this is my very first spoon fed. I spoon fed 2 bytes, just an X and a Y at addresses 0 and 1, and they show up on the screen. So at that point, I knew I had it working, and the board that I did it with. Okay, so I'm going to find the stop sharing button right there.
So
And
Curtis asked if you might be able to directly load the DP and use direct addressing instead of extended, just to save you a cycle on each write.
yeah,
Store.
but since I've got the halt down for so long while I set up the next state register, the code that Thomas showed you a moment ago was in Python, so it's running MicroPython on the thing. This is not fast. Curtis, you're absolutely right. There's a number of ways that if we ever got it going faster, wrote it in C instead of Python. But what's kind of amazing is that using the halt, we can slow everything down and just do it at a nice.
Yeah. Note that the PIO program, even if you're writing it in Python, like the Python code says, assemble this, send it to the PIO. It's very much like writing like a GPU, like CUDA code or something. Like it has to be turned into assembly and sent to it to execute.
Yeah. So
like,
the PIOs
are too small to run an interpreter
at the full 125 megahertz or something. Even though
so the PIOs are still running, like basically hand optimized assembler. Like your Python code is literally just make this for me in assembly and run it. And in raw PIO instructions and run it. So, but yeah, I wanted to see. So I mentioned that there's an Apple II card. This is not my product. The information is here on it to cite sources, and Maxwell Gadgets Apple II VGA card. But yeah, see, there's an RP2040. These are some 74 LVC 245s. It looks like 1, 2, 3, 4 of them.
Hold it up again.
That's it.
Hold it closer.
And the
4
resistors.
LVC 245s.
And the resistors.
Resistors. That's a ladder. Yeah. So that's it. VGA.
VGA magic.
So this is the kind of stuff you can do with an RP2040. And and just without the blurring in the way, here's this board again. It's way up if you want to read it.
The one that you designed.
Or do I need to? Am I backwards to everyone else?
No, you're fine.
Do I need to?
It's only backwards for you. So when you move when you move it to the left, it moves to the.
Explain the CoPico logo that's on there.
Oh, Ray made that. It's a type of coffee plant essentially.
It's Indonesian coffee.
It's
was
spelled
that
KO?
No.
Yeah, there's also a candy called that.
There's a candy, yeah.
Okay. Yeah, which is named for the coffee plant, but I'm pretty sure it isn't made of that specific coffee plant. But yeah. So anyway, so here's the board. There's your. Let's see. I guess I need to get it to stop. Here, need to zoom in on it. So Here we go.
There we go.
Weekends
Focus.
ago at the
Focus.
2 weekends ago at the Vintage Computer Festival in Southern California, Orange County, we showed people this, and we had a CoPico coffee flavored hard candies to give out as well.
So here, this is, I didn't know if we were going to need to go to a 4245, so I have an outer footprint and an inner footprint. This is the LVC 245, which does not shift up to 5 volts going back. It just lets
Okay.
it come out at 3.3, and the 6509 has been cool with it so far. But you know, if I
Right.
find problems later, and this prototype has
Well,
room
the
for
thing
it, right?
is-
And then that's Yeah.
These new chips switch to 3.3 so fast that counts as a hard yes, even where the native signal would slope up towards 5 slowly. And so you have to
Oh,
drive
yes.
it all the way to 5.
reset has
And
reset has some interesting behavior because of this. Yeah.
but you can hit it so hard that you've got your full 3.3 right away, and the 6809 says, okay, yeah, that's a 1. You know, that counts. It just seems
Yeah,
to work that
you
way.
can drive it.
Yeah,
Yeah,
it-
with the LVC 245 drives it hard enough. Yeah.
where if you hung a big cap on that line and slowed that thing down, it might not quite read that 3.3. You know?
I mean, like you can't do that to reset.
Well, I'm just saying in
resets.
general, as far as
Yeah,
level conversion
yeah.
goes, a good hard
Yeah,
3.3 that switches quickly more than makes up for missing a volt on the top.
Yeah.
You know, it's
Yeah,
actually
I mean
do-
the
I was going to say we actually do need to try this with the 6309, where it's got CMOS inputs, because we've been doing it on the
oh,
6809
the pull
with the
resistor or the
NMOS
pull diodes
inputs.
might diode
Yeah.
your.
But
yeah.
on
I
CMOS,
was
your
figuring there'd be
criteria-
some quirky situation.
Yeah, CMOS.
That's why I had room for the
voltage should
4245.
be, midway between the rails at 2.5, and on these other technologies, it's probably somewhere between 0.4 and 2.4 is the criterion. So 3.3 counts as a
1.8, 2.0 on in the 6809 specs. I think,
Uh-huh.
data sheet. Is the cutoff point where it's allowed to call it a 1.
Mhm.
Yeah, but
Yeah, so in the back of the board is here. We've got you spin it around. Thank you. You can go look on the website. There's actually
Post the link.
incorrect. Don't go to this URL. It's copico-project.github.io.
So
Not
is it
CoPico.
so is it CoPico or CoPico? CoPico?
Both.
You can say it either
Both.
way. I don't.
All
Tomato CoPico.
It's like KiCad, KiCad.
KiCad, KiCad, yeah. So-
Tomato, tomato. Okay.
Yeah. So.
Yeah. You should say this the opposite of the way you say KiCad.
Okay.
However, whether you say GIF or GIF, you have to.
Right.
So yeah. So yeah. One of the trials and tribulations we had was I didn't realize that it was going to be Chinese New Year, so I had to get these made
Yes.
in Denver for 10 times the price.
Oh.
If you want quick turnaround in the U.S., you're really gonna
You're
pay.
paying, yeah.
Yeah, it was 30 something a board, 10 times the price.
I hope the
So-
quality was worth it.
Oh yeah, I mean,
They
I
were.
can't melt this solder mask no matter how much I mess it up.
Yeah.
Well, then you-
It's
they're
really
good
solid.
quality.
USA.
Well, and then you turn around, you buy the boards in China, and the boards cost you $50, but the shipping's 120. So
Yeah.
Yeah, I mean,
Can't win,
you
yeah.
can't be in a hurry getting it back from China.
no.
That's exactly the time they'll misplace it on the truck for 3 days. So, and there's no refunds for unless you pay an extra 100 on shipping for international. So, and usually, it's yeah. So, but yeah, I haven't had to rush things back and forth from China in a while. I worked back when I first came to Silicon Valley 10 years ago. I worked for I was actually in Malaysia working for them at the CM facility. So that's where I kind of got to see how the assembly process works and the way of soldering and the testing, all that stuff. Was out there for a month.
How sausage is made.
That's interesting.
Yeah.
Yeah, I mean, I mean, I guess there's one thing that kind of stood out to me. It was that the engineers, they got paid, a darn good wage for Malaysia, for the senior ones, nearing six figures. But the line staff there, they were also working 12 hours a day, 6 days a week, like we were, and they were not paid that. No. So yeah, I just like I tried to be extra nice to them because I can't change how how the system works, but offer them some the lunch was really cheap at the CM facility. It was like $2 for lunch. It's like 50 cents for this entree and stuff. And this was like below this was in Penang, so it's not the cheapest place in Malaysia. So, but yeah, they sponsored the meal. They what do you call it? You basically pay for the meals in the factory. But as long as they pay them, I don't think that makes up for it. So anyway,
it's been
any
an
other
hour.
thoughts about this? Yeah.
We started a little late, but yeah, we're about the point.
So by
to keep this down to an hour.
By the fest, you're going to be all done, right?
By the fest, I will have something working with Strix.
No pressure.
Cool. Demo time.
And there may be some invited to you who are known to be want to participate or can are going to work with it there that we could sell some to. But it's not going to be like, hey, everybody come buy one, because they're going to buy it and just trying to sit there if they don't want to use get and put the latest firmware on there and do things. So at a minimum, really you need to help file bugs and debug stuff. But yeah, hopefully it'll be I'll have some of the capturing the contents of the bus at least working to show, if not available, usable enough for others. And of course I want to that version to be able to at least emulate an 8K ROM. Why not any amount of ROM? So that remains to be seen whether it'll just be 8K. Because if I use a shift register, I probably won't. Yeah, I mean, I can have some of the bits on a shift register and connected directly. It doesn't have to be in one specific way. Depends on what I'm using for.
You could do it
There's
with a lot less. You could do it with a 1K ROM that changes. Where you
I meant the magic ROM. Like if we can spoon feed, we certainly can have a magic ROM that when you hit the last address, suddenly the upper half is the next 512 byte block. And yeah, that was the first thing I said. You just make a magic ROM. Whenever you read the very last byte of the ROM, then the upper half of the ROM is
full again.
Yeah. You just jump back to byte 512 and read to 1023 again. And when you hit 1023, it'll give you the next page, and then you just need to copy it all. Kind of like spoon feeding. And I intend to get that work, on this one. So, yeah. But if people want to be able to emulate, I mean, are the games, are they 16K or usually mostly 8K for the older games? Like these games.
I think it varies, right?
Are they 16 or 8? Yeah. I mean, they don't say on there. Oh, I don't want to tear them all open.
Well, because the games are kind of weird in that they kind of bend basic and take over. So
yeah,
you've got two different concepts of what is basic and what is a ROM game. And so then you've got I've got 16K ROM games or 32K ROM games. But then if you're in basic, you've only got the 8K basic space where you can smash into something else. And
well, they're not written in basic.
Well, no, I'm just saying as far as memory address,
basic.
The concept of the way a ROM loads and the way a disk cartridge loads are completely different. And when a ROM game loads, forget basic, forget the disk cartridge. The ROM is what you load. And so it's two
It's gonna
completely
overwrite.
different systems that you've got to adopt. Am I a
So it'll
OS
completely-
cartridge or
I
am
mean-
I a game? You can't be both, you know? Do I abandon basic
But
and be
they-
a game, or do I,
Yeah.
you know, or am I an OS cartridge and I have to preserve basic and preserve the disk basic and super basic and I
So
didn't mean
does
to-
so basic still loads first, right? Like even though the game is going to clobber basic.
Well,
right
no,
afterwards,
because
right?
when you plug in a ROM game, it pulls the interrupt line. And so basic
Okay.
abandons everything and says, run the game.
So basic just initializes the screen and then runs the game.
I don't know the exact sequence, but basically, yes.
Okay.
It's,
Yeah.
so all
the
of the
screen
other
turns green, and
concerns
then
are
the game
gone, and you can use all
Yeah.
of the space for
Yeah.
ROMs.
Yeah, I have a jumper on mine to connect Q to cart because I noticed that that's what you do when you're going to be a game.
A game.
So I have a
exactly.
physical jumper for that, not a software jumper yet.
So you get two different results if you do that, or if you just kind of hop in
Yeah.
on top of the ROM space at C.
Curtis says that on the Coco 1 and 2 that they went from 2K to 4K to 8K. Coco 3 are usually 16 or 32K, and with two additional
Yeah.
hardware registers.
Oh,
Also,
with
he
their own
said
hardware inside.
ROM games can also.
I got like a
Oh,
RoboCop
RoboCop. Yes,
128.
exactly.
I need to open it. I want to see what it looks like inside. That's why I got it.
Some
There
are
you
very
go.
boring. They just
Yeah.
put the chip directly on the circuit board. They put a.
Oh, there's a
blob of-
cob glob
Oh,
and
yeah.
maybe one more chip
Yeah.
outside of it.
Because I
Yeah,
tried taking
there's
one
somebody
and
on eBay
reusing
who's
it.
the first time I went to buy Dungeons of Daggeroth, I thought there was. I mean, I didn't read the thing closely. I thought I was going to get the cart. I got this. I mean, it works. It works
Yeah.
fine.
Of course.
But you know,
Curtis says that some
wanted
games
to-
also call basic subroutines like pull key and keyboard and joystick and stuff.
so they don't all wipe out, all of the basic stack space and stuff.
Don't have to.
Well, you don't have to, but
Yeah.
you're given the opportunity. That's what
Of
we
course.
should say.
He says
Mm.
RoboCop and Predator, one is 64K and the other's 128K. Doesn't remember which one's which.
And our
This
favorite
is-
game
Uh-huh.
for Coco 3 is this one. So far.
Shanghai. You need to get that signed.
Yeah. Oh. The
All right, he'll.
Hey,
I wonder,
Coco
will
Fest?
Rick be at the fest?
He should be.
Cool.
oh, cool. Awesome. All right. That's I think I've covered what I wanted to cover. So
Good deal.
Well, we're going to see what you do with it because this is looking fun. It's
well,
another thing to
hopefully
do
I'll
with
get
Coco.
things cleaned up and interesting enough that others will jump in.
Mhm.
Yeah, especially once the support is there in Frog.io, or if Frog.io gets renamed, whatever it's called next. And as well as the Axiom ROM. Like, the first thing's going to be getting Axiom ROM working in there, as opposed to this spoon feeding here. At least we could copy load the Axiom ROM and then run it. That's
Mhm.
sort of the 1K solution. So
Well, thank you for
Okey doke.
presenting, and it looks real interesting.
Thank you.
And, yeah, I'll be interested in getting one. I like
Mm.
collecting network stuff, so I'll be there.
Mhm.
So this is the last one of this virtual fest. I originally got 7 people to commit to a slot, and one of them was me, and I let Julian Brown have the rest of it so he could show off some more of his dragon stuff. And Brett had to drop out, but that's okay. There's always later. Anyway, so 5 of these. So I'll be wanting to do this next year, just because I think if we promote it a little heavier, starting about 6 months out, I think we'll get a little better turnout. Anyway, thank you for being here, Thomas and Strick, and of course, thank you, Rick, for
Thank you.
piloting.
Hopefully everyone will get a chance to watch it online,
Yes, I
like they
should.
do the regular weekly show.
Yeah, I'll have to upload to YouTube because for some reason it didn't pick up the stream start. But Twitch is working, and so is Facebook. But I'll get it on YouTube too. So
All right, cool.
let's see, and I guess we'll sign off. And this is the last one, and we'll be looking forward to more projects from you in the future. So everybody say goodbye.
All right. Thanks, Mark.
Bye-bye. Oh,
Bye,
yeah.
folks. 90
Yeah,
days
well-
to the other fest.
Yeah. 70, actually.
Yep,
So
yeah, 69.
60.
69.
Yeah.
Yep. So get that on your calendars. I think we're all going to be there. So, okay. Bye, y'all. Streaming is now going down. Okay, we're clear.